Hello friends, in this video we are going to understand about selection rules for principal axis. There are two basic rules you have to understand for selection of a principal axis. The first one is you have to consider such an axis which has highest fold of symmetry. Let us take an example of BF3. In BF3 there are three two-fold symmetry, that means C2, and one three-fold, that means C3. Thus there are two axes, one having C2 where n is equal to 2 and one having C3 where n is equal to 3. Thus we have to consider such axis which has highest fold, that means n value is maximum. Here it is 3, therefore you will consider for BF3 C3 will be considered as principal axis. Now for instance, if you have same number of n value for the axis, then which axis you have to consider? Same order, then you have to consider such an axis which is passing through maximum number of atoms. Let us take an example of an allyl molecule. As you all know, in allyl molecule there are three C2s. Now all the axes have similar value of n. Out of these, which axis should you consider for as a principal axis? For that you have to consider that axis which is passing through maximum number of atoms. That means this C2 will be your principal axis because it passes through all the three carbon atoms. C infinity axis. Now in some case you will get any number of orientation, you will get symmetrical orientation. So this rotation, any rotation will give identical orientation. For example, HCl, H2 or any linear molecule, you will get identical orientation at any degree. So for such molecules, you will consider n value as infinity, C infinity axis. Now possible number of symmetry operation, if you consider axis of symmetry, then possible number of symmetry operations will be n minus 1 because the nth will be the original. Nth will be the original. For C2, for example, if you have a C2 axis, so C21 where theta is equal to 180 and C2 of 2, that is this is number of operation. The second operation, it is 360 degree rotation. 360 is nothing but original, that is identity E. So there will be only one operation in this case because n minus 1, nth will be the original. So number of operation will be n minus 1. If you consider C3 axis, that means rotation about 120 degree. So C3 120 degree, C3 240 degree and C3 3 will give back our 360 degree rotation, that is our original. That means this will be your identity E. So number of operation here you have to consider as 2 only. So the order of axis that we have to define, that will be n is equal to 360 by theta where theta is minimum angle to give identical orientation, and the nth will be the original structure. Which will be the principal structure? Principal axis. Principal axis will be the of higher order, or you can say one which passes to maximum number of atoms, and remaining all other than principal axis will be considered as subsidiary axis. Here you have been given some examples. For example, BF3, there is one C3, 3 C2, same way CCl4, there are 4 C3 and 3 C2. In PCl5, there is one C3 and 3 C2. Ammonia, there is one C3. Same way laughing gas, that is known as nitrous oxide, N triple bond N O. It is a linear molecule, will have a C infinity axis of symmetry. You can try this molecule for better understanding. Here further there are some example. which you can try to understand that what type of rotation it is given. Here these are the example of C2 axis of rotation. H4 is rotated and comes here, takes the position here, and the structure, so obtained structure will be the identical structure. Here also, if you rotate the molecule by 180 degree through this axis, the axis which is perpendicular to the plane, so this H2 will come and rotate and take the position as H4, and H4 will rotate and take the position of H2. In the same way, other elements or atoms will take their respective position after 180 degree rotation. In this diagram of benzene also, you can see there is more than one C2 axis. Here also, if you rotate from this axis, 1 and 4 will exchange the position. B1, Br1 and Br2 will remain as it is. Same way here also, this axis passing to between the bond of the carbon atom, you can consider as 180 degree rotation, and it will give identical orientation. So these are some of the example you can try and find out which will be the principal axis of rotation. Thank you.